Hello everyone, this is Mohammad Assojaman Jabin. Today I am going to present our class project presentation on comparison study of different machine learning and deep learning approach on Twitter sentiment analysis. Our research problem is to know about the people's opinion on prime minister election campaign of a certain candidate. We basically compare two machine learning algorithm and also a deep learning algorithm. We took the dataset from the Kaggle. You could find the dataset into this reference link, and the size of the tweets is 162K, and the data already labeled with like negative is -1, neutral is 0, and positive is +1. And the class distribution is negative number of tweet are 23%, neutral 33%, and positive is 44%. And it's basically the data has two attributes, and the clean text is basically the tweet, and the category is a numeric value like -1, 0, and 1. It's basically the sentiment. So you could find the reference code here and also the data from the Kaggle. So basically overall we will show the output or workflow of the of our project or sentiment. First, we need to access and load the data, and then we have to pre-process and then derive the feature and training and testing and evaluate the result. So how does the data look like? So it's basically a tweet. For example, when Mr. Modi promised something, then the problem happens. It's a negative tweet. So and there is another one like asking his supporter prefix choke there. That means it's a positive, it's already labeled there. So these tweet are the training set, and the category is basically the sentiment, and it's already mapped. So mapped here. And then we just need to take this text and then clean the data and like remove all the, like here is a double quotation here, you can see it's already removed here. So it's a clean data. And then we need to tokenize the data. That means we need to break the sentence into a couple of words, like the important words. And then we need to, like, if there is any uppercase, then we need to convert it into lowercase. And then if we need to check like unwanted words are removed, like HTML tag, and sometimes like the any unwanted article vowels or the preposition are removed from here. And then we need to assign a tag for each and every words, like Modi, Mr. Modi, it's a noun, and promise, it's like a verb, and minimum, it's something related to adjective. So we need to like get the adjective to extract the sentiment from the sentence. And then we just need to do the limitize. That means we just need to have to take the few important words which could represent the whole sentence at most. And then we just need to take and train our model with this lemma string. So, and this is the model architecture. So for machine learning, and all looks same, but the pre-processing are same. Like we need to tokenize, like break the sentence into small words, and then we need to take the lemma, and then we need to like do the stemmer. Stemmer is like the words which are look similar, and the pause it means like the main context of the tweet. And then stop word, we need to remove some stop words, and then we need to do the feature extraction and then apply the machine learning model. But in deep learning, we don't need to do feature extraction. Here, there's just an embedding layer. So we are doing here with the BILSTM. So we don't need this like feature extraction method. So what we did in machine learning approach, first we did the like data accessibility and just load the data, and then we just need to do the pre-processing for before pre-processing, you could like found some missing data and some like the duplicate data. We need to do that, and then we need to like do some sentiment analysis. Like we need to assign the mapped sentiment, like for -1, assign negative for +1, assign positive for 0, assign neutral. This is the like map sentiment. And then we need to check the distribution. It's basically the visualization of the data. Like the number of negative twists are 23, neutral 33, and positive is 44%. And then we need to do the feature extraction. So before feature extraction, we need to do some pre-processing, like remove all the HTML tag, HTTP links, and also some unwanted characters from the text, and also remove the punctuation mark, and also remove the Twitter tags, and also email address. And then we need to do word lemmatization. Or lemmatization is basically do some tokenizing first, and then we need to pre-process and do the lowercase part, and also remove the stop words, and also like apply all the things into one function. So here we are using like count vectorizer as a feature extraction function, but you could use like IDF vectorizer or hashing vectorizer, but we just found that count vectorizer gives like maximum accuracy. That's why I just use this one. And the number of maximum feature was 2000 here. The stop words are looks like this, like the English is to means are like the article, vowel, some preposition. And next we have to do some feature scaling here. So fit transform will do the feature scaling. The output of the feature scaling will be like this. And then we need to split the data. First, we did the like 80:20 for training and test, and then divide the train into like 40 validation. So overall, the trained validation and testing percentage is 40, 40, and 20. And then we just apply the machine learning algorithm. First, we did the naive Bayes algorithm. So for naive Bayes, we use Bernoulli algorithm, and here the learning rate is 1, but in baseline code, alpha was 2. I just changed the alpha and then trained the model and like measure the accuracy. And for the tuning in part, we need to do the cross validation part. Here I use like 10-fold cross validation here. So, and then for the tuning part, I just use like alpha equal to 1 and it just tuned the model. But for SVM, I use linear SVC algorithm where the tolerance was like 10 to the power -5, and the penalty is L2 regularization, and the loss that I counted is like square hinge loss. So but in terms of BioLSTM, like deep learning part, the pre-processing part is almost the same. And then I just take the like pre-process data and then apply the tokenizer. Tokenizer is basically convert the string into an integer sequence. Since we are using BioLSTM, it's a time, for BioLSTM, it's a like time series. So time series basically should be like sequential data. So we just convert the word into sequence. So this is the text to sequence is basically used to like convert the string into a sequence. And then we just need to do the mapping again, like because we are dealing with a numerical value. So just -1 again, just convert it, because I use the same code. I apply the same code, like apply everything into a single file. That's why we need to map it again. And then just training, split the data set into the same accurate, same ratio like as before. And then ensure the padding. Padding is basically like the number of sequence shouldn't be like equal. So we need to do some padding to make it like the same length. And then we need to do the BioLSTM training. So here, the first layer should be embedding layer, because we didn't use any feature extraction. So embedding is a like feature extraction. So the number of unique lemma words is this one, like the 113K. And then we need to, in second layer, we need to use BioLSTM with 100 nodes, and then we need to use dense fully connected layer. But if we use 128 nodes in dense, the accuracy is 98%. And if we use like last layer as like as a dense tree, and then you will get like 98% accuracy again. And you could like check the binary cross entropy loss or category entropy loss both at a time. So the result part is like my baseline code, the code that I took from the GitHub. The accuracy was 70% for NetBIOS and 81% for SVM, and for BioLSTM it was 64%. But after I changed some parameter, I got 75% accuracy, and for SVM it is 89, and for BioLSTM it is 93%. So you could find my code in this Google Colab link. So this is the output of some BioLSTM part. So this is the most commonly used tweet word into my dataset. And this is the like word stemmer. Stemmer is like our algorithm could like detect the same, detect the word as the same. Like care and care are both are same in for to our model. So it will help to like to omit like the repetition of the word. So this is the accuracy, like the loss is like this. So loss is decreasing, and this is the validation loss, and this is the training accuracy, and this is the validation and accuracy. So it looks like it's quite stable. So in summary, we use like 40/40:20 for the splitting. The accuracy is 93%. That is the maximum in BioLSTM. For SVM is 89 and NetBIOS is 75. But overall, SVM for in terms of like time processing, SVM is the best. But in terms of accuracy, BioLSTM is the best. And NetBIOS is like quite low for the accuracy and also time processing. So in BioLSTM, we use 128 dense node, and we got 93%. But if you change the node, then you will get like less amount of accuracy. For SVM, we use count vectorizer as a feature extraction, and the learning rate was 1, and there is a L2 regularizer there. But if you use TF-IDF vectorizer or hashing vectorizer, the accuracy decrease. And if you use NetBIOS, you could use like 10-fold cross validation. The accuracy is the best, is 75%. But if you change the learning rate, it will decrease. So in next future plan, I could check like some the other deep learning approach like GRE algorithm, or I could use like transformer based model, Roberta algorithm. Thank you.